in this problem, it told us to determine all the roots for x to the fourth minus 7x squared minus 18. You should notice that you are missing some terms. Yesterday we learned that the p-value is the last number. Now it doesn't include the negative sign. And we would list out all the factors. That basically just means the numbers that multiply to be 18. 1 times 18, 2 and 9, 3 and 6. Your Q value is the number in front of the leading term, or they call that the leading coefficient. So your Q value is just 1 in this case. And then basically yesterday we did a bunch of divisions. So you have 18 divided by 1, 9 divided by 1, and so on. And then these are all pluses and minuses, which basically means that you have all the positives and all the negatives to test. So basically we have 12 numbers to test. And yesterday we left off that we know that 3 and negative 3 works. So let's go ahead and try that. So I already know that 3 works. Why would I put 3 in here? Because it kind of helps me find out the rest. Class, what numbers should I write? 1. Pay attention. 1. Should I put negative 7?
0.
No, 0. So 0, that should be a plus. Plus 0, negative 7, 0, and negative 18. Raise your hand if you had that. So it's not a trick question. You just have to have your placeholders. We've done that before. Bring it down. Multiply. What do you get? Class, what do you get?
3.
Add.
3.
Multiply. Add. Multiply. Add.
2.
Multiply. Add.
0.
If the remainder is 0, then it is it's a factor. And this is the reason why, green for good, that is the reason why I checked off a 3 over here. Okay? Then it tells us, rewrite the original polynomial as a product. Class, am I going to write x plus 3? Yes or no? No. What am I going to write? X minus 3. The reason why is that this is x equals 3. And you would have to subtract both sides to get a binomial. Okay? Let's write out the rest of this. So now I'm going to use these numbers to fill out the rest of my polynomial. Let's start on this side. This is what I would do. So what do you write? Plus or minus? What's the next one? 2x. So add an x. Positive or negative? Next one? Plus or minus? And then the last one. X to the third. And then essentially what you're going to do next is you're going to write ooh, I see something. Okay, math. If you don't see it, math is very forgiving. You get second chances. Okay? So yesterday we learned that you can use the rational roots theorem again. Test your numbers. You already have another number to test, and I already gave you a clue that it works to factor this. But there's actually another way to factor it as well. Raphael! Alright, Raphael. We're going to be using this now to test more numbers, right? Doesn't matter where you write it, so I'm going to do it over here. Raphael, what should I write inside? And what number did you write here on the outside? Yeah. Lucky I told that to you. On your quiz or test, I will not tell you which ones work. Alright, Raphael, go ahead and do this for us.
So jump in the 1. 3, 6, 18, yeah, 18, 20, 60.
What happened?
Isn't it free?
Oh, yeah, you're right. We already used 3. Good job. We already used 3. And that was supposed to be what? Negative 3. Alright, Raphael, let's do that again. Raphael, go ahead and multiply. So it's a factor. Okay, so let's write what we have so far. We have x minus 3. We have x equals negative 3. Class, how do I write that as a binomial? X plus 3. Remember, this is x equals negative 3. To set this equal to 0, you would have to add 3. The binomial would be x plus 3 equals 0. And this last one, what would I write? X squared plus
2.
You don't write the 0, right? Plus 2.
Okay, plus 2.
Okay, for now in this class, I'm going to say this would be our best answer. I could write this with imaginaries, but for right now, this would be the best. So, what's the purpose of the rational roots theorem? It's very difficult for a student to go from here to here. So, what do? If you list out all the p's, all the factors, divided by the q's, you test your positives and negatives. Once you get one of them to work, then you can keep making it smaller by using synthetic division. Now, did anyone see here that you could have factored by grouping? So you actually didn't have to use the rational roots theorem. You could have just factored by grouping. But if you didn't see it, it's forgiving. You can still use the rational roots theorem.
Love man.